Hello, welcome children to the discussion of PYQ questions JEE Advanced. And here we have one more question, JEE Advanced latest, 2023. 2023 latest exam question we have, which seems to be a comprehension type question, a paragraph type question. How many questions are there? There are two questions. Two questions based on a comprehension, a paragraph given. Let's go through. It's given a trinitro compound. It's given a trinitro compound. What is that trinitro compound? 135 tris 4-nitrophenyl benzene. 135 tris 4-nitrophenyl benzene. So this is 135 tris 4-nitrophenyl benzene. Very easy to understand. This is 4-nitrophenyl should come at 1, 3 should come here, right? And 1 should come here. I hope it is pretty good, right? Let us verify once again. 135 tris 4-nitrophenyl benzene. 4-nitrophenyl benzene 135. Isn't it perfect? Good. Fine. Now, that is on complete reaction with the excess of SnHCl. Give major product. Excess of SnHCl. Tin with HCl, you know what will happen? Tin with HCl. Excess. All NO2 will be reduced to NH2 group. All NO2 will be reduced to NH2 group. So what will be the result? NO2 reduced to NH2. Isn't it NCERT reaction or not? Isn't it in the NCERT or not? Yes, it is the preparation of amines. First method NCERT. Preparation of amines. First method NCERT. It is NO2 turn NH2. NO2 turn NH2 with the excess of SnHCl or iron with HCl or catalytic reduction, all of you know. So that is point number 1. Now which on treatment with the excess of NaNO2HCl at 0 degree produces P as the product, that is diazotization. This is treated with the NaNO2HCl at 0 degrees Celsius. There will be diazotization reaction. You get a diazotization product. What happens? The entire system, it will turn diazonium group, isn't it? You get diazonium group is produced. What you find will be NH2 will turn. NH2 will turn. That 2 is given excess. You will get N2 plus Cl minus. N2 plus Cl minus. N2 plus Cl minus, like this. So you get diazonium salt. Right? So nitro reduced to NH2. That diazotization we got diazonium salt. What next? So that is product P. That is product P. This compound is termed as product P. Good. Fine. P upon treatment with excess of water at room temperature give the product Q. Diazonium salt treated for hydrolysis. Diazonium salt treated for hydrolysis. You get phenol. This treated with excess of water. You will get phenol. What you get is phenol. NH2 group, that N2 plus Cl minus will be expelled. And you will get phenol. The group obtained will be NH2. I'm going to replace with phenol, as I have just taken the copy to make it simple. See that this group, each of this group will escape. N2, N2, N2. 3N2 will escape and you will get phenol. Method of preparation of phenol. We are learning that. Right? And that in fact is the compound Q. Yes, that is the compound Q. This is compound Q. This is compound Q. And further what happens? Bromination of Q in aqueous medium furnishes product R. Bromination of Q in aqueous medium. In aqueous medium there will be exhaustive bromination. As we are dealing with the phenol derivative, there will be exhaustive bromination. And what happens with the R? With the R, this taken for exhaustive bromination in aqueous medium, what will happen is there will be bromine substituted at all possible ortho para product. I think no para is possible here, isn't it? No para is possible, isn't it? You see, this para position is occupied, so it will be bromine coming here and bromine coming here and bromine coming here and bromine coming here, isn't it? Yes, here we have bromine here and here, isn't it? Right. So that is what the product, what it is termed as R. That is the product written as R. This is R. What next? Is it over? No. The compound P upon treatment with excess of phenol under basic condition give a product S. Compound P. What is P? This is P. P treated with excess of phenol. How? That is coupling reaction. P treated with excess of phenol. P treated with excess of phenol. There will be coupling reaction. There will be coupling reaction and the product obtained will be like this, right? It's going to be a product like this. Right. Let me eliminate these groups because it's going to be diazonium product. Azo product is going to be there. Azo product. See, there will be azo, there will be azo, there will be azo. Azo coupling will be there. So we get NN like this, isn't it? This is what the azo product at one place and that will repeat at all places. You will get here also NN coupling. NN coupling here also and one here required, right? Yes, here also one NN coupling product. Oh, no space. Okay, fine. Good. That is product yes. This is product yes. I think the reactions are over. We arrived at P, Q, R. Yes, now comes the question. The number of heterogeneous atoms present in one molecule of R contain how many heterogeneous atoms? R contain how many heterogeneous atoms? This is R. And how many heterogeneous atoms? You see 1, 2, 3. 3 heterogeneous atoms in one place. So it will be 3, 3, 3. It is 9, right? Isn't it? 3 over here, 3 over here, 3 over here. It's a symmetric molecule. So 3 into 3. 9 will be the answer for that first question. That's really beautiful. So it is 9 is the answer for the first question. Let me tell you once again. 1 bromine, second bromine, 1 OH. And that pattern will repeat here and here. So 3 into 3, 9 is the answer for the first question. Clear? Right. What about the next question? Second question. The total number of carbon atoms and heteroatoms present in one molecule of S. We are talking about S. We are talking about S. This is S. We want to know how many heteroatoms and how many carbon atoms. How many carbon atoms? Carbon atoms are available in the ring, right? This is containing 6 carbon atoms. So it is 1, 2, 3, 4, 5, 6, 7. So it is 42 carbon atom, isn't it? 6 over here. Any other carbon atom present? Any other carbon atom? It's only carbon atom present in the benzene ring, right? A carbon atom only present in the benzene ring. So here you have 6. 1, 2, 3, 4, 5, 6, 7 benzene rings are there. 7 into 6. Okay. So it is 42 carbon atom and how many heteroatoms? How many heteroatoms? We want the sum of heteroatoms and carbon atom. Here you have 1, 2, 3. Here you have 1, 2, 3, and that will repeat here and here. So it seems to be 9, right? 1, 2, 3. So 3 here, 3 plus 3 plus 9. So it will be 9 heteroatoms. 9 heteroatoms. 9 heteroatoms. So it will be 42 plus 9, 51. 51 the answer for the second question. 51 the answer for the second question based on a long sequence of reactions which was dealt NO2, symmetric molecules given NO2 reduced to NH2, diazotization, diazonium salt is obtained, treated with water you get phenol derivative, bromination you get bromination like this. That was an essential part of the question, asking how many heteroatoms in the final product obtained in this sequence are. Now this treated for coupling reaction, excess of phenol you get like this. That also is a symmetric molecule, but there the question is slightly different. They are asking how many heteroatoms plus how many carbon atoms. So understanding the reactions is important, and finally taking an account of the number of atoms is also important. Hope you understand and enjoy the question, and we will meet with another question in next class. Okay, bye, see you, take care.